All right, so hopefully everything is going to be working. I'm going to be using the mouse to actually do this. I record my lessons every year to try and make sure that I am on track with what I was previously doing to what I am currently doing. And every group of students are different. So I got to actually try and train myself on how you people actually learn. Some people learn by having both earbuds in and not paying attention to anything that I'm talking about at all. Okay? But I'm not only talking to those people. I'm talking to all the people that are here listening to us and paying attention. So right here we have limits of functions using numerical and graphical techniques. So let's go through, and since I already printed off the notes for you guys, for you people, right here. Now, so you guys actually did some of this stuff already. So this is actually going to be a refresher. Discuss the slope of a tangent line to a graph. So if you notice, my function that I have, y equals f of x, is a curve. Tangent is specific to be only having the slope at a single point. I can move this point anywhere, and it's going to tell me what the slope is of that tangent line. So remember, tangent line, it's going to touch it at a single point, and it is going to be the slope of my function at that single point. Yes? All right, so next one. A circle. I could go around a circle and actually do the same thing. So in the circle, I could actually go all the way and keep wrapping around. My tangent touches at a single point. It's a straight line. Okay, equation of a straight line, y equals mx plus b, right? Y equals mx plus b, where m is the slope. B is the y-intercept, right? There we go. Okay. So along with that, so if you take a look at what we have here, so we have a tangent line here, and then L1, L2, L3, okay? Figure 4, 3 lines, L2, L3, wait, where'd L1 go? Okay, exactly 1 point, common in a circle, shown here, where definition does not work. So the 3 lines, L2, L3, contain the point P, right here, exactly 1 point in common in the graph, but they do not meet the requirement of touching the graph at point P. The other hand, the line, L of T, okay, there it is. That's my tangent line. The cursive is killing me right now, and this is not as big as it should be. So if you're watching online, I apologize. I suck at reading right now. So just remember that when you're watching the video later. Okay. All right. So touches the graph at point P, but intersects the graph at other points. It is the slope of the tangent line T that distinguishes it from all other lines containing point P. Now, it has to have the slope at that singular point. That's the big thing to go along with that. So the slope at that point, there we go. Okay. Now, we actually have an equation for this. We have the m of tan, so that means the slope of the tangent line at the point. Okay, and the location of point is going to be C and f of C. What does f of C mean? Can someone tell me what f of C would mean?
The I of the function at f of t.
Yeah, so what did I do with the C?
Input it.
I input C into the function to get the output, or in this case, the y value here, right? That's what that means. Now, a secant line touches it in 2 points. So it's going to be an estimate of the slope of the line in between 2 separate points. Okay, the line containing the points P, C, and f of C and Q, which is x and f of x, is called the secant line of the graph. It has the slope m of secant, That's important because secant touches at 2 points. Tangent touches at 1 point. There we go. That's important. Distinction. Next one. Okay. So if we go ahead and actually move this at a different place, so we're actually going to use different lines. If you notice, as we go from our secant line right here, if you notice there is a big area under that line in which that it is not touching. So it's above the graph, but as we get closer and closer, this is the limit process here, the limit process eventually gets me to the point of having the slope. To get the slope, all I need to have is 2 points, right? Rise over run. That's all I got to do, rise over run, or my slope formula to try and do that. But if you notice, the limit process for the tangent, it approaches C. So what that means is it gets closer and closer and closer to the C value. So that number is approaching 0. So it's, instead of actually having 2 points, it's going to be 2 points that are really, really close together to the point in which that they are so close together, they are mathematically the same. And that's what we do to go from the secant line to get the slope of the tangent to get that one right there. Is this a limit process you guys actually saw before? Or I didn't know how you guys actually did yours. No? You guys didn't do it like that?
We didn't. We didn't have that in last year, but I took it.
I thought you guys said you did do limits.
We don't go into depth with the
derivative two was like limit f of x approaching, and we just write the points approaching.
Oh,
That's
okay. Oh, all right, good. Okay, so now you guys are actually going to find some reason for actually doing that. Is we're trying to get to the point where as x approaches c, where the x value is way over here, and the c value is over here, as these two numbers get closer and closer, that they're automatically going to be on to c. So as it approaches that number, as the distance in between those two eventually becomes 0, that it's mathematically going to be the same number. So I'm going to find the slope given that. So there's a process to go along with it. So if you are a highlighting person or underlining person or a circling person, see that formula right there? That would be a really good formula to try and pay attention to. But you ain't heard it from me because I am a gossip. Guess what? I'm gossiping right now. I'm trying to tell you that's important. Do you want some highlighters? You do? Okay. Anyone else? Yeah. You got one?
Oh no.
Oh, okay. I got like cool stuff, but no one actually wants to share. I made it. Look, it's brand new. If I forget you, I didn't want to share with you. Anyway, so that formula right there is going to be important for this. So as we keep referencing this, this is going to get more and more important. Idea of a limit. The whole big idea is of finding the limit where the two numbers, the distance in between, where we'll eventually start referring to it as delta. Anyone know what delta is? Okay, the Greek term in delta mathematically refers to the change of. Okay, slope formula is actually delta y divided by delta x. Rise over run. The change in the y divided by the change in the x. So delta y over delta x is the changes, which is the rate of change, which is the slope, which is the slope formula where we get to. Now, so the limit process is actually going to get me to this. So that capital letter L is always going to be referred to as the limit. So when you see a capital script L like that, that refers to a limit that we have, where it is approaching something. So as the secant approaches that limit of those two things, those 2 points, is going to be the slope. of a tangent line touching at that singular point. Okay. Interpret this limit expressed symbolically. All right, what does it say? What is it saying? What you got? Not you. What you got? You weren't paying attention.
The order of the function, x squared minus 1 divided by x plus 1 as x approaches negative 1 is 2 or negative 2.
It's negative 2. So the number that it is approaching, but can I just plug in negative 1? Why can I not plug in negative 1?
Because the denominator of the function is 0, which makes it defined.
Perfect. Good job, man. You know what? You have earned yourself another one. Good job. Okay. So it's going to be undefined. That means that's bringing us up to domains. Now, what can I not have? Can't have 0 in the denominator, right? No zeros in the denominator. Can't divide by 0 unless you're Chuck Norris. You divide by 0. He counted to infinity. Twice. No? Okay. Wow, I'm just super old. Anyway, so mathematically, how would you try and do this? What would be one way of actually looking at trying to do this?
Look at the numbers bigger than.
What? I mean, that's weird.
Not negative 2. How about negative 1? Because negative 2 is my answer, right? So if you're looking at this, how would I go through? I'm like, okay, if I cannot plug in negative 1, if I can't plug in negative 1 because that's going to be 0 in the denominator, can I plug in something larger? Yeah. Can I plug in something to the other side? Yes, I can. So I could plug in a negative 2, and I could plug in a 0, those ones, and get closer and closer. As those numbers get closer and closer to negative 1, okay, that's my limit process. I'm actually trying to get closer and closer to that number right there. Now, I am going to write on the board for those people watching at home. It's not going to work out because my smart board's not working. So, can I factor the top? Yeah. What does that factor to be?
X plus 1 and x minus 1.
Very good. And it's divided by? What happens because of this?
The x plus 1
Cancels out, right? That cancels out. Now, mathematically, in limit process, this is going to give me a whole. Because in the function, the entirety of the function, I still have to include the whole thing. But since I'm going to cancel this out, this is going to give me a whole. And since I cancel that, now I'm asking for the limit as x approaches negative 1 of x minus 1 is going to give me negative 2. So this is a process, one of the processes we're going to go about doing and going through. All right, you guys feel pretty good about this so far? I threw a whole bunch of stuff at you already, so you guys got your books, you got your AP classroom set up. I haven't set up the Canvas yet because I was waiting on that one, okay? Because we don't have any assignments yet because you're just going to stare at it, and for some reason, I don't know why, but you know, if you want to, we can. Now, I'll set it up later this week and have you guys have stuff on there for the class syllabus and stuff like that. So as of now, I'm going to leave you guys alone. Okay, if you guys want to actually go through and look at your textbook for this, do you guys want the second book today or no? Because I have another book for you, but it's for you to own and keep. It's an AP test prep. Do you guys want it today or do you want to take it tomorrow? It's another take it and leave it home. Because, yeah,
How big is the book?
it's,
Oh, you bring us home too?
yeah, it's a big workbook.
Right
It's
now?
it's almost the size of that.
Today?
Could I get it tomorrow then?
Yeah, you want to get it tomorrow? Okay, because I don't want you guys to carry too much. All right, make sure you guys all like, share, and subscribe. Hit that notification button, support my channel, buy stuff from the merch store. I'm going to have a new merch store here.